During the period he was working in Los Alamos, von Neumann became intensely interested in computers. Dr. Herman Goldstein, now of the IBM Corporation, was one of his earliest collaborators in this work. In the spring of 1966, Dr. Goldstein was invited to visit a warehouse of the Smithsonian Institution in Washington, where the original Princeton computer is stored.
Johnny would have said mercy. Here it is. All these years. May I move the curtain? Sure, be glad to. Let's see what it looks like. If I can do it. Very good. I succeeded.
There you are.
Yes.
Well, I leave, you know.
All right, thank you.
Thank you, Dr. Goldstein.
This machine was the concrete embodiment of von Neumann's very great ideas and contributions which he has made to the electronic computer field. In 1946, Johnny asked me if I would join him at the end of the war in Princeton and help him to carry out in concrete form the ideas which he had been working on in 1944 and 1945. Of course, I jumped at the chance. We rushed to Princeton and got started. The machine that eventuated from that is the one you see here, and it contains essentially those things which the modern computer has in it, although in somewhat primitive form. This machine has stored program concept as its major feature, and that, in fact, is the thing which makes the modern computer revolution possible. The older machines required one to clumsily perform hand pluggings of connections which took hours, indeed days. It meant that programming was an art, in fact a very black art, and furthermore it meant that the total number of instructions one could write were comparatively small. This new concept has been carried so far today that programs are written involving tens of millions of instructions, whereas in those days, of course, nobody dreamed of such complexity, but Johnny's idea made this basically possible. What is this stored program concept? Well, it's the notion that you can describe in a finite number of words, in fact, a fairly small number of words, in a fairly simple language, exactly and unequivocally the description of a problem, and that this description is then translated into binary digits and stored in the memory of the computer exactly as numbers are stored. This was the discovery by Johnny. You may say, what's so remarkable about that? Well, the only thing I can tell you in answer to that is it's just like the wheel. What's so remarkable about the wheel? When you look at it, you can't conceive how anybody would not have known that there was one. Indeed, it must have been that the moment somebody mentioned the wheel or somebody mentioned the stored program, everybody around us obviously knew that this was the way to do it. And in fact, we accepted it immediately. It was not one of these inventions or discoveries which is enormously complicated and few people can understand. It's tremendously simple. It immediately hits a person and he knows